Welcome to the class, dear students. Today we are going to start chapter number 8, which is redox reactions. So here in this chapter we are going to know about what are redox reaction. I hope from class 10 your basic knowledge about redox reaction is clear, but yet let's begin it. We all know that chemistry deals with varieties of matter and the change of one kind of matter to other. This transformation of matter from one to other occurs through various type of reactions and various type of processes. And out of those various types, one important category is your redox reaction, where a number of phenomena which can be both physical, biological, they are concerned with the concept of redox reaction. Here the importance of this reaction is apparent from the fact that burning of different types of fuels from obtaining energy for domestic transport or other commercial process, electrochemical process for the extraction of highly reactive metals and non-metals, manufacturing of chemical compounds which include caustic soda, operation of dry and wet batteries, and corrosion of metals, all fall within the purview of redox processes. Means whatever the things which we see around us, everything, whatever the reactions occur, they are all termed as redox reactions. And now we are going to start about this redox reaction. What are they? So the classical idea of redox reaction, which is oxidation and reduction. Now this is known to you from your 10th level that initially oxidation, it was used to describe the addition. It was used to describe the addition of oxygen to an element, or a compound, because of the presence of this dioxygen, or because of the presence of this O2. Dioxygen means O2. uh, in the atmosphere, most of the elements combine with it, means most of the elements which are present in the earth crust, they combine with this O2 oxygen, dioxygen, and they are available in the oxide form. So see, whatever I am talking about, these reactions will further clear it. You see, this O2 means oxygen is available in the atmosphere in the form of O2, and magnesium metal, it combines with oxygen and it forms MgO. Similarly, this S and O2, they combine together and they form SO2. This S, this G, they are the state. This S represent the solid state and this G represent the gaseous state. And similarly, if somewhere is L, it means the liquid state. So initially the addition of oxygen to any element, that was defined as oxidation. So here this magnesium is oxidized by the addition of oxygen to magnesium oxide. Similarly, sulfur is oxidized by the addition of oxygen to sulfur dioxide. But as the time proceeded, the definition broadened. Means the definition was not only limited to the addition of oxygen, like oxidation was not only defined as the addition of oxygen, but now it is defined as the addition of oxygen or any other electronegative element to a substance, or the removal of hydrogen or electropositive element from a substance. Now these things, they are quite perplexed for you and it's not clear. So you see these reactions one by one. In this case, you see what is happened here is this magnesium element is reacting with F2, and these two, they combined together and they have formed MgF2 in the very first reaction. In the second reaction, similarly, Mg is combining with Cl2 and they have formed MgCl2, means magnesium chloride. And another third reaction, let's see. In the third reaction, magnesium is combining with sulfur and it is forming magnesium sulfide. Now come to the topic of electronegativity. Now from your concept of class 11, class 10, you know that if we are comparing the electronegativity of two elements, the element which lies on the left side of the periodic table, that is less electronegative, and the one which is present on the right side, that is more electronegative. Now if we are comparing in between magnesium and fluorine, you can clearly see that fluorine is more electronegative and magnesium is less electronegative. Similarly here, magnesium and chlorine is more electronegative, and in this case also sulfur is more electronegative. Then in all of these cases, what you can see in the product phase is that the electronegative element is being added to your less electronegative element. So, as the definition is said here, as the time proceeded, the definition broadened, and now it means here oxidation. Oxidation is now defined as the addition of oxygen or an electronegative element. Now, in all these cases, you see, in all these reactions, you don't have oxygen anywhere. Here, no trace of oxygen is present. Only we are talking about those elements which are electronegative in nature. And electronegativity is comparable. Comparable means we have to compare in between these two, which is more electronegative and which is less electronegative. So if the addition of an electronegative element is happening to an electropositive element, then that is known as oxidation. Now, as this is here once again summarizing, the term oxidation is now defined as the addition of oxygen or an electronegative element to a substance, or the removal of hydrogen or an electropositive element. For them also we have some examples here, you see. Now, reduction. Now, similarly, in the previous class in your 10th, you studied that the addition of hydrogen to any element X, if it is forming XH, then that is known as reduction. But similarly for reduction also, as the time proceeded, the definition broadened in this case, and here it is defined as the removal of oxygen or an electronegative element from a substance, or the addition of hydrogen or an electropositive element this time. Okay, it is defined as the removal of oxygen or the removal of an electronegative element. See, this will be clear when we will be seeing this example. Now, in this example, you see what is happening. Earlier, we had mercuric oxide, and in the product phase, what is happening? Oxygen is removed here. Here, oxygen is removed. Oxygen is removed. So, from the definition, removal of oxygen is happening here in the first reaction. The removal of oxygen has happened. In the second reaction, you see what is happening here. FeCl3 and H2, these two reacted, and what is the product? FeCl2 and HCl. Now compare the reagent and reactant and the product. In the reactant phase with iron, I had 3 chlorine atoms attached here. I had FeCl3. Now if you compare the electronegativity of these two elements, iron lies on the left side and chlorine lies on the right side of the periodic table. So in between these two, chlorine is more electronegative in compared to iron. So now in the product phase, what is happening? One of the chlorine atom has left the iron atom. You see, there is a removal of electronegative element. Earlier I had Cl3 and now I have Cl2. So according to the definition, removal of electronegative element has happened in the second reaction. Means in the second reaction you have removal of electronegative element. Here removal of oxygen is there. Removal of oxygen is there. In the third reaction, you see what is happening. Here I had CH2 double bond. CH2 means this is a ethene molecule. In ethene molecule I have added hydrogen. Now you see here the addition of hydrogen is occurring. Earlier 2 hydrogens were there, but in the product phase I have 3 hydrogens attached. So here the addition of hydrogen is occurring. It means here you can see the addition of hydrogen. Here you have addition of hydrogen, and in the last reaction you see what is happening here. In this case, you see what has happened in the last case. In the last case, in your product phase, you have HgCl2 plus SnCl2 you have. In the product phase, what you can see is that, you see, in the product phase, in between mercury and chlorine, mercury is a metal, and chlorine is a non-metal. In between metal and non-metal, metal is a electropositive and non-metals are always electronegative here. Non-metals are always electronegative. So in this case, what is happening? One extra electropositive element is added to the electronegative element. You see, the addition of electropositive element to a substance. Means here what was my substance? My substance was HgCl2, and to it we have added another mercury, means one electropositive element is added here in this case. So this is again a reduction. So these four examples, they depict the four properties of your reduction, or the four condition which satisfy reduction. Means either the removal of oxygen should be there, which is occurring in number 1, either the removal of electronegative atom should be there, which is occurring in number 2, either the addition of hydrogen should be there, which is occurring in number 3, or the addition of electropositive element should be there, which is occurring in equation number 4. So these are your definition of reduction. Now this definition of reduction, now reduction is no longer only the removal of hydrogen. It is defined as either the removal of oxygen, removal of electronegative atom, or the substance or where addition of hydrogen or electropositive element is occurring. So you are not only limited with these two definitions of reduction, one more is added, and that is in terms of electrons. Now what is that one more definition you see here? Now in this case, in the last reaction, in the previous reaction, you can see here, in the previous reaction here, this last reaction, if you are looking here, see in the last reaction, in case of last reaction, in the first one, what is happening, this first atom here, one electropositive element mercury is added, but similarly in the next one, what is happening, one electronegative element is added. Earlier there were only 2 chlorines, but here you have 2 more chlorines added. It means here you have reduction, but in this case you have oxidation. In the same reaction you can see two things, and that is why this reaction is written separately. Now here you can see that in mercury case, in this case you can observe reduction, this is reduction, and in this case you are observing oxidation. Now why oxidation? Because electronegative element is added, and here why reduction? Because electropositive element is added. So now here what is said, you see here the simultaneous oxidation of stannous chloride, means this is named as stannous chloride, to stannic chloride. This is stannic chloride is also occurring because of the addition of electronegative element chlorine to it. It was soon realized that oxidation and reduction always occur simultaneously. They always occur simultaneously. Hence the word redox was coined for this class of chemical reaction. Means there is no such reaction where only oxidation or only reduction can occur. These two reactions are always complementary to each other, and they will always occur simultaneously in the same reaction, and that reaction where both reduction and oxidation occur, that reaction is named as redox reaction. So here this is a redox reaction, this example is this complete reaction, this is the example of a redox reaction. Now if we move backwards in these reactions, you see here also you can see reduction and oxidation in all the cases. You see what is happening here, from mercury oxygen is removed, but in this case you can observe reduction. But what is happening here, earlier oxygen was alone, but here you have 2 oxygen, means oxygen is being added to oxygen, so here you can see oxidation. Similarly in this case FeCl2, one electropositive element is removed, electronegative element is removed from this case, but here with hydrogen what is happening, with hydrogen one electronegative element is added, so here in this case you can see oxidation. Here in this case you can see oxidation, here it is reduction, here it is reduction. In the last case it is already seen. And in case of organic reaction, this is the organic reaction. In case of organic reaction, you can think in that way that here addition of hydrogen is occurring, but hydrogen is being added, means with hydrogen, earlier my hydrogen was alone, only H was there. Now if you compare the electronegativity of hydrogen and carbon, the electronegativity of carbon is more. It means my electronegative element is being added to hydrogen. It means hydrogen is being oxidized here. Hydrogen is oxidized. No doubt this is being reduced. This is reduced here. Hydrogen is being added. But to my hydrogen, I have added an electronegative element. So here we can observe that this hydrogen is oxidized. And the last reaction I have already shown you, especially in the last case here. Here means everything is happening according to the sequence, and so this type of reaction was termed as redox reaction. So a reaction where both oxidation and reduction occur simultaneously, that reaction is known as your redox reaction. Now, redox reaction in terms of electron transfer. Now, what is electron transfer reaction? Redox reaction in terms of electron transfer. Now, till now, in the previous cases here, we were talking about the atoms. Means if one atom is coming and being added, then either that will be reduction or oxidation. But now we will be talking it this oxidation and reduction in terms of electrons and how they are discussed about. You see here in these cases. In the first, some reactions are given. You see, in all the reactions, what you can see is that oxidation is occurring. And why oxidation is occurring? Because everywhere I can see that this one is added, an electronegative element is added. You see, chlorine, electronegative, oxygen is being added directly here, so this is definitely oxidation. And here in between sodium and sulfur, sulfur is electronegative and that is being added. So in every case I can see here oxidation is being occurring in the reaction. No doubt reduction is also there, but reduction at this stage you are not able to see, but when we will proceed further in this reaction you can check it out. Here also you can see oxidation clearly, and similarly here also you can see oxidation clearly. In all the cases you can see oxidation clearly. But now what is actually happening here? Now we know that these bonds, when a metal and a non-metal bond, metal and non-metal bond are formed, and non-metal bond, they are always ionic in nature. Now ionic in nature means what? Ionic means there is a complete transfer of electron. I think you have drawn in your 10th level the formation of NaCl molecule. Na, sodium, only the outermost electron will take part. Na, and this is your Cl. Now in sodium, when the formation of NaCl molecule occurs, only the outermost electrons they used to take part. Now here in sodium, how many outermost electrons are present? Then I have, in case of sodium, I have only one outermost electron, and in case of chlorine I have 7 outermost electrons. So now ionic bond means my electron will completely get transferred to chlorine. This electron is getting transferred. So now in this case what is happening? Na will become a positive and chlorine will become negative. Means this above reaction, this can be represented in the same way, because this is the thing which is happening, and this positive negative, they are attracting together. Similarly in the second case what you can see is that Na and plus O2 is there. Now Na plus O2 I can represent as Na, this is positive, again O2 negative. Now since two negative charges are there, that is why here you will have two Na positives. Here you will have two Na positive. Now Na and this 2 we have to balance, so this will come here, a 2 will come here. Now in this way, in this case also you are seeing that the transfer of electron is occurring. Similarly in case of sulfur also you can see that two sodiums are there. It means that two electrons are loosed, and those two electrons are accepted by your sulfur atom. Means in each of the cases this metal is donating electron to this. In each of the cases you can see that they are donating electron to the non-metal. So now here what is suggested that, see, this is a complete reaction where Na is reacting with chlorine to form NaCl molecule. Now the atom which is giving electron, we say that that atom is oxidized. That atom is oxidized, and the atom which accepts electron, that we say is reduced. Similarly here sodium is oxidized and oxygen is reduced. If you see, the above reaction suggests that half reaction. Means why half reaction? If we are talking only in terms of if we are talking only in terms of donation, then the above reaction suggests that half reaction that involve loss of electron. Now half reaction means only the giving part, only the giving part. So which is losing electron? Sodium is losing electron. So we see that sodium is oxidized here. And similarly the half reaction that involves the gain of electrons. Now another half is, if this has given, then definitely chlorine has to accept. Then this half reaction, the acceptance of chlorine, that is termed as reduction. And now we can see that oxidation and reduction both is occurring in the same reaction. So again this is also a redox reaction, this is also a redox reaction, and this is also a redox reaction. So here it may not be out of context to mention here that the new way of defining oxidation and reduction has been achieved only by establishing a relation between the behavior of species as per the classical idea and their interplay in the electron transfer change. Means the classical idea is there. What was the classical idea? That either the addition of oxygen or the removal of oxygen is there. In case of reduction we have removal of oxygen, and in case of oxidation we have addition of oxygen. That classical idea is there, but to that something more is added to the definition, and that is the electron transfer. Means oxidation and reduction that we can also determine by the transfer of electron. That if electron is being transferred, we will say that that is being oxidized, and if electron is being accepted, then we will see that it is reduced. Now you see the reaction, this reaction. Now I'll be using only one, anyone. I think I'll use the first one. Now in the first case I'll write it here. You see, in the first case what is happening here, you can see the first reaction was your two sodium molecules. They were reacting with chlorine atom to form sodium chloride, and when we balance it we will get a 2 here. Now if we are writing the half reaction means in terms of, first in terms of sodium, then in terms of chlorine. Let us see what is happening. First of all, sodium atom, it has loosed electron. When sodium atom has loosed electron, it means Na has become Na positive, and plus it has loosed one electron. But now in my reaction, how many sodium atom I had? I had 2 sodium. So it means if 2 sodium are there, then 2 Na positive will be formed and they will release 2 electrons. Now if these 2 electrons are released, then somebody has to accept these 2 electrons. Now these 2 electrons are accepted by this Cl2 molecule. So this Cl2 will accept it. These 2 electrons, they will be accepted by chlorine and they will form 2 Cl negative. This is the thing. Now when you add this, when you are adding these two, then what do we know that if how do we add? Left side equal to right hand side. Then let us do add the left side, then add the right side. How you will get? You will get 2Na plus Cl2 plus 2 electrons negative, and that is forming your 2Na positive plus 2 electrons plus 2 Cl negative. Now in a equation we know that the same thing on the same side, on the different side of equation, they can be excluded. So we can exclude these two, and since these two have opposite charges, they will attract each other and this will form your 2NaCl molecule. So here it is shown that how electron is transferred from one of the atoms and how it is accepted by other, and how this complete reaction occurs in terms of your electron transfer. Similarly, the another one also you can do where you had Na, then Na will again lose Na positive, it will become, and plus electron. Now in the second reaction you had 4, so it will be 4, then again it will be 4 here. Now this 4 electron, it has to be accepted by oxygen. Now we know that O2 that accepts 4 electrons. Why 4? Because the valency of oxygen is 2. Then 1 oxygen will accept 2 electrons. Then 2 oxygen will accept 4 electrons. Then that will become your 2O2 negative, 2O2 negative. Now they two will combine and they will form your Na2O. Now whatever we have studied, it is said that oxidation is the loss of electron, Reduction, it is the gain of electron. Oxidizing agent means the acceptor of electron. Now here you see Na plus Cl. I'm just writing it in a general form. NaCl. Let's balance it. 2 and here I have got 2. Now here we know that oxidation means the loss of electron. Then which is losing electron? Sodium is losing electron. Which is accepting? Chlorine is accepting. Now these two are given name. See, the one which accepts the electron. Now in this reaction, which is accepting? Chlorine is accepting. So chlorine is known as the oxidizing agent. This is known as oxidizing agent. And donor of electron. Which is the donor of electron? Sodium is donating the electron. So this is known as the reducing agent. Reducing agent. Now here one thing is reversed. What I will say is that atom which undergoes oxidation, that will be your reducing agent, and the atom which undergoes reduction, that will be your oxidizing agent. It is a bit confusing, but if you see this chart again and again, you can understand it. Oxidizing agent means the one which will accept the electron, the one which will accept electron, and reducing means the one which will donate the electron. So this is your oxidation reduction in terms of electron transfer. Now let's see another, oxidation number. Now this is a very new thing for you people, and you have never heard of it, and this is a new thing for you. Now what is oxidation number here? Oxidation number, it denotes the oxidation state of an element in a compound, which is ascertained according to a set of rules. Now we have certain rules for this. Now what does it denote? See, suppose we have an example of, suppose, water formation. Suppose we have H2 plus O2, and that is forming your water, H2O. Now if you are balancing this, you will get a 2 here, and you will get a 2 here. Now here, so this is not very simple to visualize, yet we can think that the hydrogen atom is going from a zero state to a positive state in H2O. Now what is this? You see certain rules are there. First of all, let us see those rules, then I'll tell you how to calculate the oxidation number or oxidation state of a particular element. See, first case is that in elements in the free or the uncombined state, means if any element is present in the free state or uncombined state, the atom will have an oxidation number of 0. Means if any element that is coming to your mind, means which is present directly in the periodic table, like magnesium, like iron or nickel or cobalt, all these elements, they will have a oxidation number 0. Means metals in the uncombined state, they have oxidation number 0, whereas we know that non-metals are diatomic because they cannot exist alone. So H2, O2, Cl2, these non-metals in their uncombined state, they will have an oxidation state 0. So at this time, at the time being, you just keep in your mind that oxidation number is just a number. It is just a number which is given to an element in a reaction. At this instance, you just keep this thing in your mind that the oxidation number, it is just a number which is given to an element in a compound or in a chemical. Now for ions which are composed of only one atom, the oxidation number is equal to the charge on the ion. Means if you have, suppose, Na positive, means this is a compound which is consisting of a single atom and it has a charge, then this will have a +1 oxidation number. Means the oxidation number is equal to the charge here. But that also in case of only one atom, only one atom. Suppose you have O2 negative, then here the oxidation number is -2. If you have Mg2 positive, then that oxidation number is +2. If you have Cl negative, then the oxidation number is -1. Similarly, oxidation number is just the charge which is present on the element in one atom case. Now you cannot say that in case of CO3 2 negative, this 2 negative is the oxidation number, because here this is a group of atoms. More than one atoms are present here in this case. So here ions composed of only one atom, the oxidation number will be equal to the charge on the ion. Next is the oxidation number of hydrogen is always plus 1. Means the oxidation number of hydrogen will be always plus 1 except when it is bonded to metals in binary compound. Means if hydrogen is bonded to a metal like NaH, then in that case the oxidation number may be minus 1, but other cases this hydrogen has always the oxidation number plus 1. And halogens, halogen means fluorine, chlorine, bromine and iodine, they always have the oxidation number minus 1. See, they have the oxidation number minus 1 when they occur as halide ions in the compounds. Means if you have NaCl, then here the oxidation number of chlorine is minus 1 and the oxidation number of sodium here is plus 1. Now we have certain formulas for calculating this. We will be looking it, maybe possible today or in the next class we will be looking into it. Next is the algebraic sum of the oxidation number of all the atom in a compound must be 0. In polyatomic ion, the algebraic sum of all the oxidation number of the atom of the ion must equal to the charge on the ion. Now what is said here? Let's see. I'll show you what is said in this case. Now it is said that the algebraic sum means whatever the sum that you have, that sum should be always equal to 0. Suppose you have NaCl. Now this compound, it do not bear any charge here. It does not have any charge. So now I say that sodium has a charge of plus 1 and chlorine has a charge of minus 1. So the sum of the oxidation state of a neutral molecule should be always equal to 0. The sum of the oxidation state of a neutral molecule should be always equal to 0. Now you see similarly for MgCl2, what is the charge for Mg? It is plus 2 and for chlorine it is minus 2. MgCl2 we have. So if for one chlorine I have minus 1, then for two chlorines I will have minus 2. So now if you add plus 2 and minus 2, you will get 0. Now I'll be telling you this one how to calculate this plus 2 and minus 2, but for the time being you just remember it from your class 10 that the charge of magnesium is plus 2 and the charge of chlorine is minus 1, and I have two chlorines, that is why my charge became minus 2, and when I am adding them that is 0. Now the second part says that for polyatomic ion, means if you have CO3 2 negative, this type of polyatomic ion, then the sum of all the oxidation numbers should be equal to minus 2. Here the sum is equal to 0, but in case of polyatomic ion, the sum will be equal to the charge which is present on the polyatomic ion. This will be equal to the charge which is present on the polyatomic ion. And this is your last one, means the last topic that says here is last one. What is said? The last one. The last line says that the algebraic sum of the oxidation state of all the atoms, it must be 0, and in case of polyatomic ion, the algebraic sum of all the oxidation number of atoms of the ion, it should be equal to the charge of the ion. Now next is a summary of all the things. Oxidation and increase in the oxidation number of the element in the given substance. Now what is said? Now you came to know about oxidation number here. Now one more definition is coming here, that oxidation. What is oxidation? Suppose in the reagent phase if the oxidation number was plus 1 and if in the product it became plus 2, then we will say that there is oxidation. Another, reduction, a decrease in the oxidation number of the element in the given substance. If in the reactant phase I had plus 2 oxidation state, in the product if it became plus 1, then we will say that it is a reduction. Another, oxidizing agent, a reagent which can increase the oxidation number of an element in a given substance. These reagents are also called oxidants. Means, see, this is transferring from plus 1 to plus 2. Now this transfer from plus 1 to plus 2, it will need the help of some element X. कुछ भी हो सकता है यहाँ पर, something, anything can be there. Now this plus X will be known as oxidant. And reducing agent which lowers the oxidation number, means here what is said, this plus 2 has become plus 1 here. So how this plus 2 will become plus 1? मतलब इसका जो electron है वो कोई तो accept करेगा, somebody has to accept this electron. So that accepting atom will be known as the reductant. That will be known as the reductant. And redox reaction, which involve the change in oxidation number of the interacting species. मतलब जिसमें ये +1 +2 जो है ये ऑक्सीडेशन नंबर अगर अदल बदल हुए then that is known as your redox reaction. Thank you for watching the video up to here. Have a good day.